about slope fields and how they were on my AP Calc exam a few years ago. So they're exactly what it sounds like. We're just going to use slopes, and if you remember from the entire first half of the course, slope means derivative. So they're going to give us a derivative, and then we're going to construct a slope field based off of it. So what is a slope field and why do we use it? It's basically a way that we can visualize a family of solutions to differential equations, and it's going to give us a bunch of different slopes, and then we can visualize what the curve will look like. So it's super simple to construct a slope field. So we're going to start with this first one. We've got that dy dx equals 2x. So that's telling me that my slope is equal to 2x. So what you do is you pick a point. So I'm going to start right here with this first point here. So the coordinate of that point is -1, 1. And all you do is you plug that into 2x. So remember, my slope is equal to 2x. So I would have 2 times -1, which is a -2 slope. So all I would do is draw a little line segment in the negative direction and try to make it about a -2 slope. Okay, let's pick 0, 0, just so that we can get that one out of the way. So 0, 0. So we would have 2 times 0 equals 0. So here I would have a slope of 0. Let's pick, it doesn't matter. Let's do this next one here. That would be over 1 up 1. So 1, 1 would give me 2 times 1, which equals 2. Okay, we can fill in some other ones. Now that we kind of see how this works, let's talk about this point right here. So at that point right there, that's the point 0, 1, and 2x will be 2 times 0. This point right here is 0, 3. 2 times 0 is 0. This point is 0, 4. So in this particular one, it doesn't really matter what your y is, it only matters what your x is. So all of my slopes here, because that is -1, 0, so 2 times -1, so these will all have -1 zeros, our slopes. So all those slopes should be pretty parallel. Okay, now let's go out to another one here. So we'll start on the positive side this time. So this point right here is 2, 0. So I'd have 2 times 2 for my slope, which is 4. So it's a positive slope, and it's going to be a little bit steeper. And again, it doesn't matter what the y is, only what the x is. And then if I come over to this side, I've got -2, 0. Which is -4. So that should be the same as the other side, but just in the opposite direction. Again, all of those should be parallel. And I'm going to stop there because it's going to get just really steep after that. So that's how you construct a slope field. And then some of them are going to ask you to kind of visualize what the original curve would look like, because remember, that's the slope, and then we want to figure out what the original curve is. So if you look at these, I don't know if you can notice, but it kind of looks like it's making a bit of a parabola. So if I was to just kind of follow, when you follow a curve down, it's going to look something like that. Like that's one of the curves that could fit that. Now, I did say family of functions before because that's only one of them. Like what if I wanted to start in this section here? Or if I wanted to start in this section here? Okay, so you can see this is just a family of functions. And what matters here is we're going to have a c that we add on. I think we've talked about this when we anti-differentiate. And that c is because that's what's going to tell you about that vertical shift up or down. So there's an infinite number of curves that could fit this differential equation. Now, just for fun, remember we had dy dx is equal to 2x. So just to ask you, what would have a derivative of that right there? So as a reminder, we would be integrating both sides here. So I would do something like the integral of 2x dx, and that's just by kind of separating. I'm going to integrate both sides there. So that will give me y, because the integral of 1, you just add a y, is equal to, remember our rule, our power rule, will you add 1 to your exponent, so that's 2x to the first, and then you divide by 2, add your c, which is going to give me that y equals x squared plus c. So that equation right there would have a derivative of 2x. And you can see, hopefully it's not a surprise, that that is the original function right there. Those are all x squared curves, and then they've just been shifted up or down because of that c right there. Okay, so let's move on to another example. So this one here gets a little bit more complicated in that we are going to add in that our slope is x plus y. So we have let's see here. So we're going to pick a point. I'm going to start at that same point that I did last time. So last time I started at -1, +1. And then I'm going to substitute that into the x plus y to figure out what my slope is. So it'd be a -1 plus 1, which would be 0. So here I have a slope of 0. Then I think I went to 0, 0. So 0 plus 0 equals 0. Now, actually, if you think about it, anytime you have a negative and a positive, they're going to cancel. So this time, let's drop down to this point right here, which would be 1, -1. So anytime we have the negative and the positive, that's when you're going to have that slope of 0 that's right there. Okay, so we're just going to add these points together. Let's just do one more. So this one right here is 1, 1. So here I would have a slope of 2. This point right here is 1, 0. So I would have a slope of 1. Okay. Now, just to add in a couple more, let's see. This one's my slope of 1. Let's see. So this one is -1, 2. So again, a slope of 1. You kind of get it. And then we would just sketch a curve from that. I believe it kind of, I don't remember exactly how it goes. I know it flattens out and then shoots up, I think. Let's see, what's this point here? 1, 2, 3, -3 up 2 has a -1 slope. And this one right here is -3, so that would be a -2 slope. I mean, you get the point. Like, you just draw these little line segments and then you just kind of fit a curve to it. So we'll talk about that a little bit more in class. And that is constructing a slope field. So just draw little line segments using the slopes.